Hello everyone, this is Alice Gao. In the past few weeks, I focused on talking about reasoning in an uncertain world. Starting with a short review of probability, I moved on to introduce Bayesian networks, which is the main tool we can use to model uncertainty. After that, I talked about performing inference in the Bayesian network using the variable elimination algorithm. It's important to be able to reason in an uncertain world, but ultimately, we want to make a decision and take action in the world. Starting with this lecture, let me start talking about decision theory, which focuses on acting in an uncertain world. If you want me to explain decision theory in one sentence, I would say that decision theory is equal to the sum of probability theory and utility theory. The goal of decision theory is to determine how an agent should act in an uncertain world. In order to do this, first of all, the agent needs to be able to reason and to perform inference in the uncertain world. This requires probability theory, as we are already familiar with this from the past few weeks. Once the agent knows how to perform inference, it can derive a lot of probabilistic estimates about the different states of the world. So, is this particular state of the world, how likely is it to occur based on the evidence that it observes? Now, given these probabilistic estimates, how should an agent make a decision? Well, given the multiple possible states of the world, the agent has a preference over these states. The agents may prefer for some states to be realized than for other states to be realized. In other words, an agent has different degree of happiness in each possible world. So we can use utility theory to measure how happy the agent is in each potential state of the world. So by using the agent's utility function, we can use this to guide us towards the decision-making process. An utility function assigns a single real number to each possible state of the world, and this real number is used to measure how happy the agent is in that world. Then a rational agent can make a decision on what to do based on the principle of maximum expected utility. This principle says that a rational agent should choose the action that maximizes the agent's expected utility. And the reason we have an expectation here is because we don't know which world is going to be realized. We don't know which state of the world is going to become true. However, we have probabilistic estimates over these possible states. So using the probabilistic estimates, we can compute an expectation over our utilities for different states, and then use this to guide us in the decision-making process. In some sense, the maximum expected utility principle could be seen as defining all of AI, right? After all, this is what an intelligent agent wants to do. It formalizes the notion that an agent should do the right thing. And how does it do the right thing? It should maximize the expected utility. However, having this definition doesn't mean that the entirety of AI is solved. So for example, in order to realize this definition, in order to operationally maximize the expected utility, we have to do a lot of things. For example, we need to estimate the state of the world. This often requires observing what's happening in the world, learning, representing knowledges, and inference. And for the past few weeks, we just talked about the fact that performing inference in a Bayesian network is NP hard. So this is a very challenging task to do. In addition, the other important thing we need to do is calculate an agent's utility in each state. This might also be a non-trivial task. That's because that often, just given a particular state, the agent might not know how good it is. Often it needs to look into the future to do some search to see which other states are we going to be able to get to starting from this state. This kind of search will give us an idea of how good is this state, and we can incorporate that information into our utility function. So all of this is to say that our ultimate goal is to take an action to maximize the expected utility. However, to actually do this is quite difficult. In this unit, we are going to focus on thinking about how to make a decision in an uncertain world. In order to do that, we first have to perform inference to understand the uncertain world, and then decide on which action will maximize our expected utility. Because of this, the main tool we are going to use is going to be related to the tool we use for performing inference. So for performing inference, our main tool is the Bayesian network, and turns out to make decisions to act in an uncertain world, we will use a related tool called decision networks. Decision network is essentially an augmentation of Bayesian network. We're basically taking a Bayesian network and adding some additional components to it. So one component we add are nodes representing actions, right? Because now we have to estimate if we do a certain thing, what are its consequences? How does a particular action affect our happiness? So we need to be able to represent the action and also the relationship of the action to all the other nodes. And in addition to representing actions, we also need to represent our utility function. So how happy we are in each state of the world. So a decision network is simply starting with a Bayesian network with all the nodes representing random variables, so random events that happen in the world, plus nodes who represent actions, plus nodes who represent our utility function. That's everything for this video. After watching this video, you should be able to describe why decision theory can be seen as a combination of probability theory and utility theory. Describe the principle of maximum expected utility, and describe components of a decision network. Thank you very much for watching. I will see you in the next video. Bye for now.